In this video, I'll be completing problem number 10 from the optimization homework that says, let's assume the speed of new computers costing a certain amount of money grows exponentially over time, that it doubles every 18 months. We have to run a very time-consuming program, and we can buy a new computer one time. So if we start it now, the program will take 12 years to finish. But if we, wait a few years and buy a computer, the computer will be much faster, so maybe it will take less time to finish. And the question is, how long should you delay buying the computer and starting the program so that it will finish in the shortest amount of time from now? And how long will that take? So I really like this question, partly because you have to set up the function yourself. And so it's a little bit unlike any other optimization problem that we've done. So the first thing that I would do is I would make a chart that has t, so the time from now, and then the time for the program to finish. Okay, so it says if we start right now, so if t is 0, then it will take 12 years to finish. Okay. If we wait 18 months, so if we wait a year and a half, it will take half the time because the speed of the computers are doubling, so it will only take 6 years. So we're doing everything in years in this problem. If we wait again another 18 months, so the 3 years from now, the program will only take 3 years to finish. And another 18 months, 4.5 years from now, the program will only take 1.5 years to finish. Okay, so this is the function that we're trying to figure out. And so let's say f of t is the time to finish starting at t years. So this is a little bit tricky, but to start, it will take 12 years, and then basically every 1.5 years after that, the time will be cut in half. So the idea is that we will cut this in half every 18 months. So every number of years divided by 3 halves. So another way to think about this would be 12 times 1/2 to the 2/3 t. Okay, because that's like dividing by 3 halves. So for example, here, if we divide by 3 halves, we'll get 1. It's been cut in half one time. Here, if you divide by 3 halves, you get 2, and so it's been cut in half twice, and so on. Okay, but that's not the total amount of time. That's just the time to finish starting at t years. So the total time, maybe I'll call that capital T, will be the t years you're waiting to buy the computer plus the amount of time it takes the program to run. And it's really this that we're trying to minimize. So if we take the derivative here, if we find t prime, what we'll get is we'll get 1 plus 12 times 1/2 to the 2/3 t times log of 1/2. So that's the derivative when you have a to the x, right? And you're taking the derivative, you get a to the x times log a. And then by the chain rule, we need the derivative of 2/3 t. So that would be times 2/3. And this is what we want to set equal to 0. All right, so this takes just a little bit of finagling with the logs to solve. So let's move the 1 to the other side. So let's see, 12 times 2/3, we'll get 8 times log of 1/2 times 1/2 to the 2/3 t. And that is equal to -1. And so I'll get 1/2 to the 2/3 t is equal to -1/8 natural log of 1/2. And now I can take, let's see, let's change this on the left side to actually be just 2 to the -2/3 t. And now I can take log base 2 of both sides. And I'm almost done. So now I get t is equal to -3/2 and then times log base 2 of -1/8 log of 1/2. Okay. And this turns out to be about 3.71 years. Now, to get the total amount of time, I'll need to plug that back in to capital T, because this is the amount of time that I should wait until I buy the computer. And so I'll need to plug this in here to actually figure out the total amount of time it will take for my program to end. Now, one trick is if you don't know how to do log base 2 on your calculator, you can always do a natural log of whatever value it is divided by natural log of that base. Okay, so that's one trick that you might find useful.